Welcome to Okonko Academy. In this tutorial, we'll be taking you guys through vectors, and under vectors, we'll be taking you guys through operations of vectors, combinations of vectors, and unit vectors. Now, if you are new to this channel, I recommend that you please click on the subscribe button and also put us on post notifications and also like and comment on this video. Now, back to this tutorial. Now, a vector is used by scientists to indicate the quantity in both the quantity of a particular thing in both magnitude and direction. Now, suppose we have a vector A. The length of the arrow is used to represent the magnitude, and the point that the arrow is pointing is used to represent the direction of the vector. Now, suppose we have a vector A which is given by A. Let's make it another alphabet, maybe C, D, and a vector B which is given by E, F. When we are asked to find the sum of these two vectors, that is A plus B, what we do is that we add C and E, that is the x component of the two vectors. So you add C and E, and also you add the y component of the two vectors. I call this portion the x component of the vector and this portion the y component of the vector. So we are going to add, if you are asked to add two vectors A and B, you are going to add C, the x component of A, to the x component of B, and the y component of A to the y component of B. So in this case, you add C to E and D to F. So D plus F. So the vector A plus B is going to give you C plus E, D plus F. So let's give it values. So let's say the vector A is equal to let's say 2, 4. Then the vector B is equal to let's say 3, 9. Now if you are asked to find the sum of these two vectors, you are going to get, now I'm writing this in another form, so 2 and 4 plus 3 and 9. So we get the answer to be 5. We add the x components, we add this and this first, then we come and do this and this. So we get 2 plus 3 is 5, then 4 plus 9 is going to give you 13. Okay. So we can say same for subtraction. So if you are asked to subtract the vector B from the vector A, so A minus B, you are going to get, so we have to subtract the x component from the x component, then the y component from the y component. So we are going to get 2 minus 3, which is minus 1. Then 4 minus 9, which is what? Minus what? 5 or negative 5, anyhow you call it. Okay. Now let's move on to combination of vectors. Now this is where the technicality comes in, combination of two vectors. Now suppose we have two vectors, two position vectors, OA. Now we are representing a position vector by OA. So this is a position vector OA and another position vector OB. So this position vector are points, and we move from OA to OB. When we are asked to find the equivalent, so this one is A, this is B. Now when we are asked to find the equivalent vector is AB, right? Because we moved from position vector OA or A to position vector OB or B. So the equivalent vector will be AB. Now when we are asked to find this vector, I have a simple trick of finding it. So we say the end, you subtract the end from the beginning, So to find this vector, we are going to say OB, vector OB minus vector O what? A. This is because we moved from A to B. So we subtract the end from the beginning, So we get, let's say vector OB is 2, 4 and vector AB is 1, 1. So we get, let me erase this. So we get vector OB to be 2, 4, vector AB to be, vector OA to be 1, 1. So you get our final answer to be what? 2 minus 1 is 1. 1 ish. So 2 minus 1 is 1, 2 minus 1 is 1. Then 4 minus 1 is what? 3. So we get the vector AB to be 1, 3. 1, 3. Okay. Let's solve another example. So suppose we have a vector AC, right? AC. Then we have another vector BC. Then we are asked to find AB. Now under normal circumstance, we should draw a part so that we know how we are going to add and subtract. But I have a trick for this so that it will be easy. You don't need to draw any part to know. So what you do is that the letter that doesn't appear in this vector, which is C in this case, will be the O as we did in this. So it will be the O as we did in this. So what you are going to do is that you subtract again the end from the beginning. So we are going to get CB minus CA. Now you see, we are saying subtract CA from CB, but the vectors that was given was BC and AC. Now we have something called negative vectors. So if you have a vector BC and you want the vector CB, it's just the negative of BC, right? So the negative of BC. So if you have BC is equal to negative CB. So if you want CB, it will be equal to what? Negative BC. Good. Now you will do it for this. So you say, because we have BC, you will say CB is the same as negative what? CB is the same as negative BC. Then CA is the same as what? Negative AC. Then we come and get what? Positive here, because negative minus negative, so it will be positive. So the final answer will be negative BC minus, plus AC. So we end up getting AB, the vector AB, to be equal to AC minus BC. Right. Okay. So we are done. So for us to solve, let's solve an example. Suppose that AC was equal to, I'm going to give you the example, then you solve and put your answer in the comment section. I will put the answer at the end of this video. So suppose AC is equal to 2, 9 and BC is equal to 4, 6. Find AB. Find AB. Please put your answer in the comment section. Find AB. I will put the answer at the end of this video. Okay, now let's move on to unit vectors. Unit vector. A unit vector of a vector is a vector whose magnitude is equal to 1. A unit vector of a vector is a vector whose magnitude is equal to 1. Now, say we have a vector A with components CD. A vector A with components CD. Now, if you are asked to find the unit vector of this vector, now the unit vector is represented by this. If you are asked to find the unit vector, it will be equal to that same vector divided by the magnitude of that vector. So the magnitude of that vector. Now this takes us to finding the magnitude of a vector. Now suppose we have a vector C, D, A which is equal to C, D. The magnitude of that vector is simply finding the square root of the sum of the squares of the components. So the square of C is C squared plus the square of D squared. Plus D squared. So the magnitude of A is just the square root of C squared plus D squared. That will give you the magnitude of A. So what we do is that to find the unit vector is equal to that vector divided by the magnitude. So the vector A is simply C, D, right? So that divided by the magnitude. So this will be equal to C divided by square root of C squared plus D squared, comma, D divided by square root of C squared plus D squared. Okay. Now let's solve an example. Now let's say a vector A is equal to 2, 9. Find the unit vector. Now the unit vector will be equal to that same vector. So that same vector, let's say 2, 9, right? So let's take our time and do this. So you see the formula that we've derived here, we are just going to put it inside. So it will be equal to 2 divided by the magnitude of these 2. So that will be square root of 2 squared plus 9 squared, comma, 9 divided by square root of 2 squared plus 9 squared. Then I close bracket. So we are going to get 2 divided by square root of 85, comma, 9 divided by square root of 85. That gives us the unit vector. Thank you for watching this video to the end. Do well to like, comment and subscribe, and make sure you put the answer to your solution that I gave for combination of two vectors in the comment section. I will make sure to check to know whether you are correct or not. Thank you for watching. This is Okonkwo Academy. Please share this video to your friends.